Hello everyone, this is Mr. Underkoffler. We're going to be looking at the very first lesson of the school year, and our main goals here is to figure out how do we show work in pre-algebra and beyond. Now, when I say pre-algebra, I'm also talking about those of you in math grade 7, which, believe it or not, pretty much covers about 2/3 of the pre-algebra curriculum. So I'm talking to you guys as well, and we're going to be starting by looking at how are the order of operations used to do what we call evaluate expressions. So out in front of you, you should have your guided notes called order of operations. And at the very top, you should see what I'm showing you right here, where we have some key vocabulary. Now, you can read this to yourself. I'm going to go ahead and read this out loud. We're looking at the difference between what is called an expression in mathematics versus an equation in mathematics. You might have heard these words before, obviously, in previous years. An expression is a mathematical statement that does not have an equal sign. So it could have addition, subtraction, multiplication, division, could have parentheses, exponents, but it's not going to have an equal sign. An equation does have an equal sign. And so you can see an example here, x plus 18, that's an expression. X plus 18 equals 92, well, that's an equation because it has the equal sign. Now, more important vocabulary for you to understand. When it comes to expressions, we can evaluate expressions, which is what we're going to be focusing on these guided notes, and we can also do something that we will call simplify expressions, which we'll get into a little bit later this year. With equations, we actually solve equations. Now, we'll get into that in a future chapter into the school year, but that's a big difference here in vocabulary that I need you to be aware of. Now, to evaluate an expression, what that means is that you're going to find the value, which means find the answer, the final answer, to that expression. And the way that you do that is by following what you've probably heard of before called the order of operations. Now, what is the order of operations? You've probably heard of this before. It is where parentheses are done first, exponents are done next, then multiplication and division, then addition and subtraction. What I want you to do with your pencil is, in this blank, write out the acronym that many people use for the order of operations, and that acronym is PEMDAS. And all that is, each letter stands for the parts that you must go through for the order of operations. P for parentheses, E for exponents, and so on and so on and so on. Now, there's a little bit of extra stuff into this that we're going to dive into these guided notes. One of those things is that parentheses can also include brackets. They could also include any expression in a fraction. We'll get into that on the second page of the guided notes. Multiplication and division. You might be like, well, do I always multiply before I divide? The answer is not necessarily. You're going to do that step by going left to right, and we'll look at that on some of the examples of these guided notes. Same thing with addition and subtraction. If you think you're always going to add before you subtract, that is not true. Not necessarily true. You're going to do this step going left to right. Now, one of the big things that I need to get you guys understanding at the very beginning of this school year is that we are going to show our work in a manner that will get us ready for future chapters of the school year, including the chapters where we simplify algebraic expressions, where we solve algebraic equations and inequalities. And as we are doing these things this year to get you ready for the course called Algebra 1, which will come in your future, whether next year or the year after that in 9th grade. So what I need to make sure I do as your teacher this year in pre-algebra or math grade 7 is that I show you the best way of organizing your work, the way that is the easiest for your eyes to follow and therefore your mind to comprehend, and also for me as your teacher to be able to look to see what work you did so I can help you if you're getting the answer wrong and you can't figure out why, or if there's a certain step that you're confused about. And the best way to show your work, I have it highlighted here for you, is to work down, step by step. So let me try to make this crystal clear. Working down, good. Trying to work off to the side, bad. Yes, I'm trying to be a little humorous here, guys. Working down, good. Working off to the side, where you put an equal sign and then you do more of the work, and then you put another equal sign and you do more of the work, and then you run out of room because you already went to the far right on your paper, and now you have to go put another equal sign, and now you're down here and you're working again. This is absolutely horrible. It is ineffective. It is not easy to follow for you and for me. It's not easy for your parents to follow if they're trying to help you at home. It is a very ineffective and horrible way of showing your work. So guys, you got to trust me. I'm not trying to be a dictator here. I'm trying to be logical. Working down is the way that we are going to do starting today. And it's going to prepare you for stuff coming up later this year, and then also into the future, especially for Algebra 1 when you eventually get that. So going back here to our guided notes, what you're going to see is that I am working down piece by piece. Remember how with order of operations, parentheses is first? So we do with the stuff that's in the parentheses first, and that gives me the 4. And then I do the exponent next, and that gives me 4 to the second is 16. Then I do multiplication and division going left to right. So I do 3 times 16, which is 48. Then after that is dividing by 6, which gives me 8. Do you see how I keep bringing down the rest of the mathematical expression to keep myself organized? I'm not trying to do this to give you more writing than what's necessary. No, 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 no. I'm not one of those teachers who's all about doing extra writing just because I like to give you more work to do. That's not the kind of person I am. No. The reason we are bringing down each piece of this problem as we do step by step is to keep it organized. Guys, you're going to have some problems like this one that is very complex and multi-step before you can evaluate to get to the final answer. This is why you need to show your work like this, okay? Finally, I do addition and subtraction going left to right. So here's an example of where the subtraction is further to the left than the addition. So 12 minus 8 gives me 4. 4 plus 78 gives me 82. Notice I didn't put an equal sign anywhere. Why? It's because of what we learned at the top of our guided notes, that equations are the things that have equal signs, not expressions. So this is actually a very important thing to understand in mathematics, especially as I try to prepare you for algebra, is that with evaluating expressions, there are no equal signs. The final answer is at the bottom after you've gone step by step according to the order of operations. Now, you might have noticed these little diagonal bars. Like, for example, I did them right here and here. That is not required for you to draw as you do these problems. I did that here on the first example in your guided notes just so you could see a little bit more clearly, visually, what I did step by step, okay? But you don't have to draw those diagonal bars if you don't want to. Some kids that I teach year after year, they like those diagonal bars. You are not required to use them if you don't want to. But following the order of operations, that is a requirement whenever you evaluate a mathematical expression. All right, so a little bit lower here in your guided notes. There are many different ways that multiplication can be shown. The one way that we are not going to use is the traditional extra multiplication. Not going to use it. Why? Because this is a pre-algebra course. Even if your course is called Math Grade 7, that's still 2/3 of the pre-algebra curriculum. And so, guys, x is a variable in pre-algebra and algebra 1 and beyond that into algebra 2 and so on. So we are not going to confuse ourselves by using x as a multiplication symbol, since x is going to be one of the most common variables that we use this school year. So instead, we use a raised dot. As you see here is my first possible example of showing 18 times 9. Now, make sure that dot is raised, not low enough where you would think it's 18.9. We don't want you to think this is a decimal, so we could use a raised dot. Computers might use an asterisk key for showing the multiplication symbol. That's very similar here to the raised dot. Another way you can see multiplication is with a number next to parentheses with nothing between the number and the parentheses. And I show that down here on this example right here. When you see a 3 next to parentheses, and then obviously there's some kind of math problem in the parentheses, that actually means the 3 is times to whatever the answer is going to be of those parentheses. So that's another way of showing multiplication. And back up here you can see, the number could be to the right of the parentheses. You could have both numbers in the parentheses side by side. Guys, you don't have to highlight this as I'm talking this through. I'm just trying to show you, since this is a video lesson online, what I'm talking about so you can easily follow me along here. You could even have the number in what we call brackets, which are kind of boxier looking parentheses. So anytime you have a number right next to parentheses with nothing between the number and the parentheses, that means that number is multiplied to whatever is inside of those parentheses. Now, speaking of variables, you heard me say how x is a very common variable. N could be a variable. So if I want to show 28 times unknown number n, the most common way is to put the number right next to the variable with nothing in between. And guys, you're going to see that so often this school year. You might have seen that a little bit in 6th grade math as well. I don't know. But you're definitely going to see that a lot this school year. So get used to it. The most common way of showing a number times a variable is putting the number right next to the variable. You could technically put a times dot in between. You could technically put parentheses around the number or the variable. But guys, most common way, I put it in a box for a reason. This is how you're going to see multiplication of a number times a variable. All right, we are looking at the very bottom of the first page of the guided notes, where we have the directions. Guys, I need you to make sure this year that you read the directions, okay? The directions here say evaluate. Now, if you have already forgotten what that means, here's the beauty of my guided notes. I try to always go over the vocabulary at the beginning of the guided notes. So, if you ever forget what something means, go back in your own guided notes and find the definition of that word. And by the way, the beauty of online video pre-recorded lessons, you can hit pause whenever you need to if you have to reread something, or you can hit rewind and skip back a little bit if you need me to explain something more than once, if you need to hear it again. So right here we see to evaluate an expression means to find the answer to the expression. Find the final value, the final number that you come up with by following the order of operations. So that's what it means to evaluate an expression. So let's go ahead and look at the very first example. Now guys, problem number 1 is already done for you on your guided notes. If you're taking a look right now and following along, you'll see that I already did the steps for you. I often do that on our guided notes throughout the school year, where the first problem or two, I might already have the work done for you, and that way you can use that as a guide. This is partially why I call these things guided notes, to assist you then on other problems that you'll end up doing independently. I highlighted for you, we are going to work down, not because I'm trying to be mean or a dictator. No, 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 no. It's because I know from experience of teaching stuff at the middle school level that you need to understand how to work a problem going down step by step to get you ready for more algebraic problems, whether they're expressions or algebraic equations that come up later on in your math life or in classes like Algebra 1, Algebra 2. All right, so that being said, problem number 1. We need to follow the order of operations. Remember, the order of operations, you are supposed to do the parentheses first. Are there any parentheses on problem number 1? Clearly there are not. So, goodbye parentheses step. We now move on to the next step. The next step of order of operations is to do the exponents. Do we have any exponents on problem number 1? Clearly we do not. So we move on now to multiplication and division. Now, forgive me for going back and forth here, but I'm trying to make sure you can follow along what I'm talking about. With multiplication and division, you do this step going left to right. Excuse me. So, on problem number 1, that doesn't mean you do the whole problem left to right. It means you do the multiplication and the division pieces left to right. So, you can see 17 times 2, that is multiplication. But also 108 divided by 9, that is division. We're supposed to do multiplication and division going left to right. So 17 times 2, we'll do that first. That gives us 34. But we can also now go to the right where we had the division. 108 divided by 9, that's going to give you 12. Now, could you technically write this as two separate steps of lines of work? Yes, you could, and I would never criticize you for doing that. I would not mark it wrong. But one thing, I try to be practical as a teacher. I don't want to give you more writing than what's necessary as long as it doesn't harm the organization of your work. And so, check it out. I put the 34 from 17 times 12, or sorry, 17 times 2, and I put the 12 from 108 divided by 9. It's like I did them both at the same time, but I'm not breaking the order of operations. I did the multiplication before I did the division. And so since there was addition, which comes later in our steps, in between, I am totally okay with you doing a multiplication and a division piece kind of both at the same time if there's something in between like addition or subtraction that separates us. And that's what we have here in problem number 1. All right. Next, we do the addition and subtraction going left to right. You might have heard the phrase, please excuse my dear Aunt Sally, and that might make you to mistakenly think that since it's Aunt Sally that you always add before you subtract. I'm here to tell you that's not true. Look back at your guided notes. With order of operations, the addition and subtraction, you do this step left to right, which means whichever piece, the addition or the subtraction, whichever piece is further to the left, you will do first. And so on problem number 1, the subtraction piece, 62 minus 34, that is first. That is further to the left, left to right with addition and subtraction. So you're going to do 62 minus 34 first before you add by the 12. If you go in the wrong order with this, if you would add before you'd subtract, it would not work. All right, you got to trust me on this. So 28 plus 12, final step, gives you 40. Notice I did not put any equal sign here, guys, ladies and gentlemen. No equal signs. These are expressions, not equations. As I said earlier in this video, these diagonal bars, you don't have to use them if you don't want to. All right, problem number 2. I believe I already have it typed up for you on the copy of your guided notes. But here we go. Let's do this one together. Very first thing we look for in order of operations is parentheses. Do we have parentheses? Clearly we do. So that's the part we have to do first. 9 minus 4, that is 5. Now notice what I did. Since 9 minus 4 was the only thing in the parentheses, the actual parentheses drawing them, I don't need to draw them anymore. Parentheses now can be gone. The minus sign is obviously gone because I did 9 minus 4 and I got 5. I bring that 5, I put it underneath where it came from. This is how you work down. You put those answers step by step underneath where it came from. And then you also bring the rest of the problem down with it. So the plus sign is still there. We haven't done the plus yet, have we? The 8 and the times 3 is still there. We haven't done that yet, have we? So you bring down the rest of the problem that you haven't actually worked out yet. You bring down each of those pieces step by step until you finally get to the final answer. All right, let's keep going. Do we have exponents? No. So we don't have to worry about that step of order of operations. What's next? Multiplication and division. 8 times 3, that needs to be done before you ever add by 5, according to the order of operations. You multiply and divide before you add and subtract. So 8 times 3, hopefully you all know your times tables, that is 24. By the way, side note, if you don't know your times tables, you're going to need to get good at them. Maybe make your own flashcards, learn your times tables up through at least up through 10, if not 11 and 12. All right, last thing we have on this problem, 5 plus 24 gives you 29. Do not put an equal sign. I like to circle my answers. A lot of kids I've taught in the past like to circle their answers. If you don't want to circle your answers, I guess you don't technically have to, but do not put an equal sign, all right? No need for that. These are not equations. They are expressions, no equal signs. Okay, now is the time of the guided notes, where I would like for you to do these problems on your own based on what you've learned. So hit pause on the video and do number 3 and 4 on your own. You may do that now. And then hit play when you're ready for me to go over it. Okay, I hope you've done number 3 and 4 on your own. Otherwise, you better hit pause now and do it. I am now going to go over it, and I expect you to check your work step by step as I go over it. So, problem number 3. Should we divide first? Should we multiply first? I know you've heard the phrase, please excuse my dear Aunt Sally. And so you might think, my dear, I always multiply before I divide. No, not true. May I refresh your memory? On your guided notes, it tells you specifically that with multiplication and division, they are the same priority step. Step 3, if there's parentheses and exponents before it, and you must do the multiplication and division going left to right, which means on problem number 3, since the division was further to the left, you must do that before you multiply. That's what your guided notes tells you with multiplication and division, going left to right. So here we go. 42 divided by 7 is 6. You bring down the times 2. Now, anytime I go over a problem, whether it's in class face to face and you're actually in my classroom, or whether you're going from home and you're watching an online video, I expect you to fix your work as soon, immediately as you see that you have messed up. Guys, we're all going to mess up. I mess up still as an adult every day, all right? It's part of life. Fix your mistakes. Learn from your mistakes. If you have to rewind the video to hear the explanation so you can learn from your mistake, then make sure you do that during the school year. That way you can learn and then get better. So we divide before we multiply because the division is further to the left. So we get 6. Bring down the times 2. Now 6 times 2 is 12. And there you go. Don't be the kid this year who ignores the steps until I get to the final answer to see if you're right. You need to be the student this year who is paying attention step by step and fixing your work as soon as you realize that you made an error. All right? That's the best way to be a math student. So that way you can learn from your mistakes and do better in the future. All right, problem number 4. Do we have parentheses? No. Do we have exponents? No. Do we have multiplication or division? Yes, we do. Where is it? Way over here on the right. Now you might be like, I thought you said do left to right. You do left to right with multiplication and division. You also do left to right with a step of addition and subtraction. But that does not mean that you will go left to right on an entire problem when there's a combination of addition, subtraction, and also multiplication or division. You must always multiply or divide before you add or subtract. So here we go. 12 times 5 is 60. So we put that 60 underneath the 12 times 5. We bring down the rest of the problem. This is how I expect to see your work whenever I check it when I see you in class. From here, what do we do? Well, there is no more multiplication and division. So now we're looking at addition and subtraction, going left to right. Who's further to the left here with the addition and subtraction? Well, it's the subtraction. So 34 minus 6 gives you 28. By the way, if you would have to go off to the side and write out, the 34 minus the 6, forgive me, I can't really write really well here with my mouse and keyboard, but if you had to go off to the side and do 34 minus 6, and then do your borrowing and get the 2 and then make this 14. If you have to do that off to the side, that's fine. There's no problem with that. I call that side work. Do not put that side work in the middle of your actual algebraic mathematical steps, okay? Actually, I shouldn't have called this algebraic. Algebraic means there's variables. This does not have variables. We'll get to that in a different lesson. But anyway, what I'm trying to say is this side work, it's great. Whenever you need to do it, do it. If you don't need to do it, then don't do it, all right? But that should go off to the side whenever you need to do it, all right? And we're not using calculators, guys, yet at the beginning of the year. I need you to learn things without a calculator first. All right, so 34 minus 6 is 28. Then from here, 28 plus 60, because we're going left to right with the addition and subtraction, gives us 88 for our final answer. And that is the end of page 1 and also the end of this video. Page 2 I will do in a separate video. Thanks for watching. I hope this helped. We'll see you next time.